Remember, we were talking about simple sine waves, where we have peaks and valleys there, and great. And the next slide shows our sine waves versus time.
Did I go too fast?
Yep, that's okay. The different types of waveforms that we've got: square waves, triangular waves, ramp waves, and then the sine waves themselves. If you've been around an oscilloscope, you've probably seen this next slide, especially if there's bad distortion. You have that sine wave there, but there's a lot of garbage riding on it. And a problem that you don't want to see happen, but the oscilloscope is your friend. It'll sure point you in the right direction toward finding these issues. If we do a review from what we talked about last time about the frequency spectrum, higher in the frequency band from the audio frequencies, we reach the AM radio band. Of course, AM is amplitude modulation, and this is a picture of the WHIO AM tower in Ohio. And this is actually an insulated tower. There are 4 insulators at the bottom that isolate the tower from the ground. And in most cases, we've got smaller towers, but this one's a pretty good sized one, pretty large face. Our AM band runs from 535 kilohertz to 1705 kilohertz. And once again, in talking about frequencies, remember the 1705 kilohertz is 1,705,000 cycles per second, or hertz. So it's a lot of cycles that are going on there. Here's a picture of some AM tube transmitters. These are over at KOCX, a couple of 1 kilowatt Collins transmitters, a main and a standby that use tubes. Still on the air. However, if we go to the next slide, we can see that solid state definitely reduces the size of the transmitter. This is a 5 kilowatt broadcast electronics transmitter that is the size of a small refrigerator. The audio processor provides more consistent audio levels. It equalizes audio for best sound, and it prevents overmodulation. And this is a picture of one at the bottom. These have also shrunk in size, just like the transmitters have. Most of them are at least one rack unit high now. An AM modulation monitor. We talked about amplitude modulation. This device gives us the ability of measuring what that modulation is. In this case, this Bell R monitors both the positive and the negative peaks at the same time. And it's something that keeps you legal with the FCC or other authorities. We talked about the exciter in our last visit. Every transmitter has one, and in most AM transmitters, it's built into the box. FM transmitters, remember, have the external exciters, or an exciter that's a standalone box that may be mounted in the transmitter. The exciter generates the RF signal component of the signal, the AM wave. In this case, this is the carrier wave. We're choosing 730 kilohertz as our example. And again, that AM exciter output is 730,000 cycles per second, but it's at a very, very low level. So we need to boost that level up to get the 50,000 watts or whatever it is. And the exciter is a very small portion of the AM transmitter because it's just generating that frequency. Then it's boosted up through the tubes or the solid state devices in the transmitter itself. So with AM, you're not looking at the more complicated exciters that you find with FM. It's usually just a printed circuit board or a crystal that is used to generate that frequency. When we impress the audio signal onto the RF carrier, we change the amplitude, hence amplitude modulation. So as you see here, we've got the carrier on the left-hand side, the actual modulating wave or the audio signal. And then when the two of them are combined, you see that the audio wave sort of rides on top of the carrier wave. Here's a block diagram of the AM transmitter. You start with a master oscillator or exciter. That's where the frequency for the station is actually generated. It runs through drivers and buffers, and then it is applied to the power amplifier, where it is modulated by the microphone signal or the signal out of your console going through the audio amplifier and then out to the antenna itself. Overmodulation is where carrier pinch-off occurs. So 100% is right at the point where the pinch-off occurs. So as you see there, the wave comes down to 0, and that is considered 100% modulation. The AM transmitter will boost this power to 1,000 watts, 5,000 watts, or even more power. And even a 50-watt exciter can kill you. So it's important when you're working with these components and these pieces of equipment to remember that there's a lot of voltage there. And one of the biggest bugaboos, I guess, with transmitters is that they have safety gear inside that shorts the supplies, shorts the output, so that if the transmitter door is open, you're not going to reach in and touch something. It's important that you check those to make sure that they are working, and also make sure if you're a new engineer coming into a facility that they haven't been bypassed. A lot of guys will do that so that they can open the door and see what's going on inside while the transmitter's running, but it gives you a real sense of I guess, insecurity in seeing that, because you can reach in for something and touch the wrong thing, and that would be the last thing that you touch.
I don't know about you, John, but about 6-7 years ago, I was taking apart a old Continental 816 that had been at the site. We were installing a new Nautel solid state, and we'd inherited the site through corporate acquisition. And we hadn't had to do anything with the transmitter, so we really hadn't touched it. As we pulled it apart, we discovered a great chunk of cardboard wrapped around the interlock, down at the bottom where you can open the panel to adjust the driver grid. Well, that was nicely bypassed forever.
Boy, oh boy. Yeah, it is unfortunate. I mean, I understand that you sometimes need to do something like that, but a permanent fix is really disastrous. And once again, just a review of the amplitude modulation audio wave, the carrier, and the bottom wave showing the signals combined or modulated. I've got a little sidebar here. Why do they call it a carrier? Well, think of it that it's carrying either the AM or the FM audio signal to the radio receiver. The audio will not resonate or will not transmit. However, when you get up higher in frequencies, that is one of the characteristics, is the actual transmission through the air. So the combination of the audio signal with the carrier takes the signal to these receivers that are out in the field. Harmonic interference is an issue in AM as well. Unwanted harmonics can interfere with other broadcast stations, and there's usually a harmonic filter built into the output network of the AM transmitter to reduce these emissions. Remember, we were talking about matching the transmitter in the FM situation. Think of it as a garden hose. It means no leaks. Maximum power will be transferred. There's no water leaking out. It's going all the way through the hose and into the sprinkler. You want to occur when you have minimum reflected power. And that's why we want to check to make sure that the reflected power is minimal, the forward power is at licensed value. Got some tips here for you that may be helpful. Unfortunately, copper theft can be a real problem. Some people don't want to work. They'd rather just cut the copper and sell it, and really screws up the array. So one way of preventing that is using this compound. It's called wet or dry. And it's a tar-type compound that can be painted on copper strap. And it does a couple of things. When it dries, it's almost impossible to remove. So a scrap metal company, if they see copper brought in with this stuff on it, will tell the guys, hey, we don't want it. Most of the copper thieves know that. So if they see your copper strap painted with this, they won't even bother it because it's a waste of their time. I saw a guy a few years ago taking a pair of vice grips and trying to rip, it was like a YouTube video, trying to rip this stuff off of a copper piece of strap, and it was almost impossible. So, if somebody's looking for a quick buck, if you've got this stuff wrapped around your copper at the base of your tower, or if there's exposed copper strap and you have it covered with this, it will certainly discourage a copper strap or radio theft. Here's an example of past electrical failure. Note the burn pattern on the wall. When you walk into a transmitter site, if you see stuff like this, you really do need to address it. It is not a good way to be operating your equipment. So make sure that all of your connections are tight. We go to the next slide. Here's an example where they used a plug that was plugged into an outlet for the transmitter. It was a small transmitter that was mounted in the rack, and loose wire caught fire and burned the socket and burned the plug. So making sure that all of your connections are tight are very important. You remember last time we talked about using the heat sensitive gun to give you the ability to see whether or not things are hotter than normal. This was a new 50 kilowatt RF line, but it was not assembled properly and it started leaking. So wrapping tape to prevent leaking air, yeah, it might work, but it's just a temporary fix. What they ended up doing in this case was they came in and disassembled the entire connector and found that the O-ring had been crushed, and that was what was allowing air to leak out. The reason the line was being pressurized was because of the amount of power that was going to the AM tower, and having this stuff leak was causing a real problem, but also causing an issue with getting the tanks of nitrogen replaced on a regular basis. Important for you to keep spare fuses on hand. One of the things that I would do on a yearly basis was do a fuse inventory of all of the fuses that were in my site, whether they are the small little fuses that go on into individual pieces of equipment, or the larger fuses that went into the disconnects for like transmitters and air conditioners. It's really important to have spares available, and here's why. This engineer sent this to me, and with a question, wonder what the blow rate was on that fuse, whether it was a fast blow or a slow blow. I think it's more of a fire generating fuse. You don't want to do something like this. People do, and unfortunately, they'll do this and then walk away and forget about it, or put the cover back on and forget about it. Reason why you don't want to do this is pretty obvious, but if there were a fire because there were not fuses there, you're not going to get an insurance payout on this. So it would be quite a disaster for a station to have something like that. Really important for you to mount your transmitter site. In the studios, if you don't have windows in the studios and you lose power, giving your staff the ability to have some light, or buy those little lights that will come on when power is disconnected. You plug them into a socket, and it gives them light, is a good idea. But having a light by the door is really important. And they don't have to be expensive lights either. As you can see now, there's a picture of a LED flashlight that you can get at Lowe's, and that's on the next slide. What's nice about this one is it's got a hook for hanging and also a magnet in the back, so you can go ahead and affix these to the side of a steel rack. If you have not invested in a LEA or similar surge arrestor at your studio and transmitter site, you're missing a real opportunity. It's insurance companies, their whole purpose is to mitigate claims or reduce liability. And if you take and put something that is a safety instrument like this into your studio or transmitter equipment to take care of surges and problems like that, I have seen three opportunities. One was the insurance company actually bought this $1,000 surge arrestor because they figured it was better to pay $1,000 to the station to buy the surge arrestor than $10,000 to repair all of the equipment once it got a surge that came through and blew stuff up. The second thing is that they went 50-50. In another case, the station paid for half of it, the insurance company paid for the other half. And in the last instance, the insurance company didn't pay anything. However, they did reduce the monthly premium substantially. So it's one of those things that you want to check and investigate. It's another example of how engineers are not always just spending money to spend money. We were spending money to save money. But here's an example of mouse infestation. If you see this on the floor of your transmitter building, don't go any further. Get yourself a mask because cleaning this stuff up subjects you to hantavirus and all kinds of other illnesses, airborne illnesses. But here's a way to problem solve. It's called Bonide, mouse magic. You can get these in both hardware stores and also garden shops. These are little pouches that are filled with a peppermint extract of some sort, and the mice hate the smell. Now, your transmitter site's going to smell like a holiday tree with a nice peppermint smell, but it will definitely eliminate problems like what you see to the right there, where mice have crawled in from the outside and built a nest around that circuit disconnect. He has built his nest on top of a 50 kilowatt contactor. And these guys are just so industrious. This was a site we had cleaned out. And the very next day, the manager of the station called me up, just raising Cain with me about how he paid for me to come and do this work, and I didn't do anything. I went down and opened up the door, and doggone it if those mice hadn't just completely rebuilt their nest again. So we started looking a little closer. We found there was a crack at the bottom of the ATU that allowed the mice in. Once we sealed that up, the problem was solved. Important for you to inspect transmitter openings too. This poor bird got inside a transmitter and got across the wrong contacts there, and the result is RIP. So you want to make sure that your openings in your transmitters are sealed. Speaking of sealing things, if you have a generator outside using hardware cloth, this is a 1/2 inch by 1/2 inch mesh screen. It's called hardware cloth. It can be applied to all of the vents and openings using tapping screws and then washers, as you see at the very top of the picture. The idea is that mice can squeeze into some very tiny spaces, but they can't squeeze through that 1/2 inch mesh, and it will keep your equipment running. You don't have to worry about them getting in and chewing wires or causing a problem. Another idea that you can do is to add crushed stone around your transmitter building perimeter. The mice, snakes, all kinds of little animals don't like to be out in the open. So if you've got brush that is around your building, it's pretty much a welcome mat for them to come around and see if they can find a way inside. You greatly reduce the propensity of them getting into your building by having gravel going out 6 to 8 feet all the way around. And they don't want to be out and be exposed, so they stay away. And this gives them or prevents them from getting over close to the building and then finding an entrance way, whether it's a hole in the building or a hole in the door, or they try to chew through the wood to get into the door. Hoods are great ideas for keeping water out of buildings, especially ventilation hoods, but you got to watch out for insects and nests. A good idea this time of year when wasps are trying to find someplace warm is to just take a spritz of wasp spray, hornet spray, and spray the insides of these hoods to keep them out so that they don't come around. This is pretty sad when you think that that wire on the left is the station ground or the tower ground. You can see the picture below that where they've got a hose clamp and a little bit heavier piece of cable, but that is the ground there. Just got to be really careful that things are done properly, and that if you see this, that you make a correction so that your facilities are properly grounded. And talk about really crazy things. This was a transmitter that was installed, and there was a slot underneath where the copper strap is laying there, but the copper strap was just shoved down into that slot and never connected to anything else. The problem they were having was routine lightning and AC surge damage to the transmitter. We tugged on the copper strap, and lo and behold, it all popped out and there was nothing connected to it. So properly grounding things is really, really important. There is Harry, you mentioned Nautel. They have several white papers on grounding, and they're really good resources. If you haven't read those, head to the Nautel website and download that information. Our next picture here, a beautiful transmitter site that was put together. However, they did not do any grounding. They were going to come back the next day to ground. And we go to the next picture, and you can see what happened. Lightning struck the tower, came down and caught the building on fire. And it's a it was a concrete building, but you can see that it just really devastated it. So another example of why grounding is so important. It's also important when you're having work done at your site, whether it be electricians or tower crews or whoever it might be, that you monitor your subcontractors as they do their work. In this case, the spark gap is to give lightning a place to go to ground. Those two balls are set at the proper distance. So when lightning hits the tower and it comes down, rather than going inside to the transmitter building, it jumps across that little gap. But if the spark gaps are painted, it's going to greatly reduce the efficiency of that. So you don't want to paint the spark gaps. You want to make sure they're properly set. And, it's one of these things where these guys were painting the tower, but they just didn't know, and no one knew to tell them, hey, don't do that. You can also see where it's connected with the ground strap. That's what one of the examples I'm talking about open ground strap that gives somebody the impression that, hey, I can rip that off and take it to a metal reclamation place and get a few dollars for doing hardly any work. Saving energy and money, important for you, and switching over to LED bulbs is really, really neat, whether they be the tower beacons or they be the bulbs inside your building or even the little lamps in your console. Most of those are in the audio consoles are all LED now. A dramatic savings in the use of electricity. They last a long time. Yes, I will tell you they're more expensive, but I think over the length of time that you use them, you'll find that they are a good investment. Here's an interesting idea. This engineer used a string of LEDs over each of his transmitters and then tied it into the plate contactor to identify which transmitter was on the air. So you could walk into a facility. He had two identical transmitters, and you could walk into the facility and look and see automatically which one was on the air, so you don't go turning something off or adjusting something that you think is off the air, but you find out that it actually is. Just a little tip that's helpful. Here's something else that's really helpful is flowcharts. With CAD systems being as inexpensive as they are, and there's a lot of freeware that's on the web that you can get, you can grab pictures of the equipment that you have at your transmitter in studio and go ahead and transpose those into a flow chart. Having one of these at your transmitter site is really helpful for a couple of reasons. In the middle of the night, if you come in, you may be a little groggy and need to remember where everything goes or what's connected, especially if you're handling 4 or 5 different sites. If another engineer is coming in, say you're on vacation, and I know everyone says, what's that? But if you are taking time off, and you have someone coming in troubleshooting for you, having something like this will pretty much guarantee that they'll get the station back up a lot faster. And finally, if the program director ever goes out to the transmitter site or the general manager, if they have a drawing like this, you can point them in the right direction to check and see, okay, is there signal coming from the STL? Is there signal going into the audio processor? Is the remote control working? Whatever the issue may be, a drawing like this will be helpful for you. We're talking about changing things. Don't forget to change your batteries annually and mark your calendar. This was just a simple smoke detector, but the batteries had not been changed in a while. You want to make sure that that's done at least annually so you don't have this kind of a problem. And we go to the next slide. This is really pretty neat. A lot of transmitters have battery backups for the microprocessors that are inside them. In this particular case, engineer out in Seattle, Clay Freenwald, has come up with a little jumper. And what will happen, as you saw in the previous slide, the previous slide showed the corrosion that occurred around the contacts. What you're going to run into on this particular transmitter, this is a BE transmitter, those contacts will corrode with a battery that has not been changed and cause you all kinds of problems. So what Clay's solution was to put one of these little jumpers together, plug the jumper into the terminals on the printed circuit board and reverse the battery, and then connect the other side to that. If there is corrosion that occurs, it's going to happen to the jumper. It's not going to happen on the printed circuit board. So cheap, easy little way to solve a very, very good problem that everybody will have. Nautel has batteries in their transmitters as well. You want to, in this case, replace the batteries with the transmitter on. You don't want to remove a battery with the AC power off, because if you do, there's nothing to power the microprocessor. And the same thing with the BE transmitter. All of your readings and settings that you have in memory will be lost. Another little maintenance tip for Nautel, the Cinch Jones plugs that they have for their modules. They are nickel cadmium plating, which are good contacts. However, over the years, a clear varnish can develop, and this will cause audio dropouts or power fluctuation. And a solution to this is a product made by Caig, C-A-I-G. If you Google Caig.com, they have deoxit products that reduce the oxidation of contacts. And if you're having audio dropout problems and it's an issue with contacts not making good connection, this stuff is really great for it. Important for you to stay safe with a well-stocked first aid kit. Something that is missing from a lot of sites. You want to make sure that you have one, and make sure that when you open it, there's a good stock of first aid supplies inside. As we wrap up here, I want to tell you a story about no tubes in the boxes. When I was doing contract engineering, I got called out to a station, and they were off the air. The manager was going to meet me out there. I didn't have keys to the site, and he was going to meet me there. And he said it seemed to him that it was a problem with the tube. They'd had that problem occur before. So he said, we got lots of tubes out here. I'm going to go ahead and let you just change it. I'll wait for you. And it was a good thing that he was there. Opened up the first box. There was no tube. opened up the second box, there was no tube. He had about 8 boxes there, and all of those tubes were missing. The previous engineer had not been paid, and his solution was to send all of the tubes back to Econco and collect the $100 dud fee. That's what some people will do. My point about all of this is that if that manager had not been there with me and saw all of this, I would have been the one that was on the hook. Well, I know that there are tubes out there. What do you mean the boxes are all empty? So a good point here is we talked under the first presentation of using your camera to document things. If there are 2 boxes at a site and you're taking a tour of it, take lots of pictures, open them up, make sure there are tubes inside there. Don't assume anything. You don't want to get yourself caught in a legal bind. And these days, with everybody being so litigious, that can certainly happen. I'll take any other questions. My email is here. If you'd like me to send you a Telos Sharpie, please shoot me an email and send me your mailing address, and I'll get those on out to you. If the program has been helpful, please let me know as well. And I thank you for taking a look at the workbench column that do in Radio World, and also for your business for the Telos Alliance. I appreciate Telos's support of the SBE in giving me the time to do a presentation for you folks. So I'll take any questions now, Harry, if anybody has any.
Anyone got questions for John?
Or comments or war stories. We'll do them all.
There, we'll get rid of the screen. Now everybody can see everybody. Well, at least those that want to be seen.
There you go.
I guess if there's no questions, in a couple of weeks we have Stephen, I forget Stephen's last name, up for our final chapter on RF. Thank you, everyone, for spending part of your, well, for a lot of you, I guess, your vacation day. And John, thank you very much. It's been very enjoyable.
My pleasure. I hope it's been helpful for you all. Yes, and it's Stephen Lockwood who'll be coming from Hatfield and Dawson. He'll be presenting at your next meeting. So hope you have a good time with that and enjoy your day off. Thank you again for your time and your attention, and I look forward to hearing from you.